So today we will start with a new topic, which basically is DHCP. Full form of DHCP is Dynamic Host Control Protocol. Dynamic Host Control Protocol. Now, before we jump into the discussion of DHCP, first let us try to understand what is the logic behind DHCP. Now, till the last few sessions, right? We were assigning IP addresses on the tool. Okay, what I did, I would basically drag and drop a PC. Okay, and then I will open up the configuration bar, and then I will just enter IP. Okay, some IP like 1.1.1.1, and it will automatically, based on the class, it will automatically populate the mask as 255.0.0.0. This is what has been happening. And also when we were doing the static routing, I had two routers, R1, R2, and R3, not two routers, three routers, R1, R2, and R3. So to assign IP addresses on the interface, I would go into the interface configuration and then I would write the IP address that basically suits me. Okay. So I would write it as 12.0.0.1, 255.0.0.0. This is what I usually configure on the router interface of this router. Right. This is what how I assign IP address. And with our discussion on IPv4 addresses, we know how IP addresses are basically given to different regions of a geographical location, right? How IANA basically divides and gives away the IP addresses to different regions. This is what we had seen, right? So we know how IP addresses are usually assigned to a particular PC or to a particular router through the CLI command. Okay, but what if there is no such mechanism where where I do not have a time or the ISP do not have time to assign IP addresses to the PC? Or for that example, or for that, or in other sense, let's try to think from the laptop's perspective, our laptop or our mobile phone's perspective. Okay, we do not assign IP addresses, right, to our laptop. We do not assign IP addresses to the mobile phone. They're able to communicate, right? The moment we switch on the Wi-Fi on our, the moment we switch on the Wi-Fi on our laptop or on the mobile phone, it automatically gets connected to our Wi-Fi router, and then it starts to communicate through the internet, right? We don't do anything. We don't assign IP addresses. However, if we go and check on the laptop's command line, okay, on the laptop's CLI, okay, command prompt, and give the command ipconfig, okay, we can see the IP address that has been assigned to our PC. Okay, you may think we did not do anything. I did not go into the CLI of my laptop and then I configured an IP address. I did not do any such thing. How is my laptop having an IP address? The IP address is not preloaded on your laptop. It has not been preloaded. When you buy when you buy the laptop from your store, there is no IP address on the computer. Okay, so how is your laptop or how is your mobile phone able to communicate to the internet? It is because of this protocol, DHCP, or Dynamic Host Control Protocol. Okay, this protocol or DHCP helps. Okay, DHCP helps networking devices to fetch IP addresses. To fetch IP addresses. This is the main work of a DHCP. It helps networking devices to fetch IP addresses. Okay, to fetch IP address, meaning that it is getting an IP address from somewhere. It does not have an IP address. The networking devices do not have an IP address. They're getting or they're fetching the IP address from somewhere. And where are they getting from? They're getting from a server, which is basically called as a DHCP server. They're called as a DHCP server. It gets the IP address from a DHCP server. This DHCP server, okay, basically, if you imagine it as a big supercomputer, Imagine it as a supercomputer or a big computer or a PC or a big CPU. Okay, it stores, the DHCP server stores IP addresses. Okay, it stores unused IP addresses, not IP addresses. It stores unused IP addresses. Okay, unused IP addresses. And which unused IP addresses are these? These are the IP addresses that are assigned to the ISP. Okay, it basically stores the IP addresses or unused IP addresses that are assigned to the ISP. So obviously, that means in the world, there are many DHCP servers, not just one. There are different DHCP servers. Every geographical location. Okay, honestly, I don't know how big the geographical location has to be in order to have different DHCP servers, but different geographical locations will have different DHCP servers, and those DHCP servers will have or will be stored with unused IP addresses that are assigned to the ISP. Not just one ISP. It may be it can have different IP addresses from different ISPs also. Meaning that this DHCP server does not belong to one ISP. It belongs to different ISPs as well. Okay, it belongs to different ISPs as well. Okay, so different ISPs who have like got the IP addresses from IANA, they will store their unused IP addresses into this DHCP server. And our networking devices like laptop or mobile phones or even our smart TVs, when we switch on the Wi-Fi, okay, they get the IP address from one of these DHCP servers in our geographical location. Clear? Any question till up to now?
No, up to now it's fine.
So now the next question is, how is our networking device? How is our networking or how the networking devices are communicating with this DHCP server so that they get the IP address? Okay. Again, the question is, how are these networking devices communicating with the DHCP server in order to get the IP address? And that process, in short, it has a full form, but in short, it is called as the DORA process. In interviews, we may be asked, can you explain the DORA process? They may not ask you, can you explain the DHCP process? Basically, it's the DHCP process. Okay. But in short, they may, or not in short, in other words, they may ask you, explain the DORA process. As I said, DORA is a short form. Short form for what? We'll try to understand. So it's called as the DORA process. Now, what is a DORA process? Let's try to understand. So as I said, our PC, okay, will try to communicate with a DHCP server. Okay, this server, okay, basically is in the same geographical location. When I say geographical location, it may be in the same network, same network as this PC, okay, or may not be in the may not be in the same network. It may be both. May be in the same network as this PC, or may not be in the same network as this PC. Okay, meaning that this PC and this server, they may be in the same IP subnet. They may not be in the same IP subnet as well. Okay, they may not be in the same IP subnet as well. So if they are not in the same IP subnet, how is the PC sending this DHCP messages or the DORA process with the server over here? How is it able to communicate to a different subnet? We'll talk about that later. But for now, let us try to understand if the DHCP server and the PC both are in the same subnet. Okay, if both are in the same subnet, what will happen? Okay, now we have a PC and then we also have a DHCP server in the same subnet. So what this PC does is the PC first sends a message to the DHCP server, and that message is basically called as the discover message. Discover message. Okay, so it's trying to discover a DHCP server, and the DHCP server in response sends back an offer message.
So this message will
Okay,
be suddenly sent by the PC, or how? What is the trigger for this discover message?
the trigger is when it does not have an IP address. When it sees that it needs to, like, if it is not connected to the internet, it's okay. Okay, if it is not connected to the internet and there is no need for this PC to talk to someone, okay, it's okay.
So,
Just like our laptop. If you just simply disconnect our laptop from everything, okay, you disconnect the Ethernet, you disconnect Wi-Fi connection, or you just make our laptop into a flight mode, etc. Our laptop is a standalone device, right? It does not, and I can work on my laptop. Okay, do offline work. It's okay. But the moment my system wants to go online, okay, if it wants to go online and if it wants to talk to internet, it needs an IP address. And when it understand or when it realizes that it does not have an IP address, it sends a discover message to the DHCP server.
okay. Because
All
that has
right.
to be registered
And
first in the PC. And what is the DHCP server? Then only like
yeah. You're absolutely right. You're absolutely right. You're absolutely right. No, it does not even have to be registered where the DHCP server. I'm just giving you a high level
okay,
explanation of the DHCP process, and then I'll
process.
get inside the depth.
Okay,
Okay.
okay, sure.
What you asked is a valid question. I'll just come to that in a few minutes. So the DHCP server in response sends back an offer message. Okay. Saying that these are the IP addresses or unused IP addresses that I have. Choose any one that you want. Okay. Choose any one IP address that you like, and and just let me know which one have you chosen. So the next, after choosing the IP address, okay, that the DHCP offered, the PC sends back a request message. Okay, saying that I have chosen one of the IP address that you have offered, and this is the IP address that I want to use. Can I use it? Now the DHCP server, in response for this request message, it sends back an acknowledgement. It sends an acknowledgement message, or it acknowledges if the IP address can be used or not. Okay. And once the acknowledgement is received, the PC can now start to use that IP address. So this is what you call it as DORA: discover, offer, request, acknowledge. DORA process. So in interviews, they may ask you in either two ways. They may ask you, like, can you explain the DHCP process, or can you explain the DORA process? Okay. Many people, they know what a DHCP process is, but sometimes people forget. that when they are asked like, can you explain the DORA process? So they are like, what's a DORA process? I've never heard of it. But then indirectly they're asking the DHCP process on discover, offer, request, and acknowledge. So the PC sends a discover message, basically trying to discover for a DHCP server, right? The message reaches a DHCP server. The DHCP server sends back an offer message with list of IP addresses that the PC can choose from. The PC in response sends a request message by choosing one of the IP address and asking the DHCP server that can it use that IP address or not. The DHCP server acknowledges that you can use this IP address and it sends back the acknowledged message to the PC. Okay, this is your DORA process: discover, offer, request, acknowledge. For anyone who is new to networks, or if you're giving, or if you're fresh out of college, if you're going for a campus placement, or if you just have 1 or 2 years of experience, explaining this particular DORA process with just high level explanation is enough for the interviewer. But since we are not satisfied with this kind of answer, and I like to, not just yourself, myself also, I'm not just satisfied with this kind of answer. I like more details. Okay. And if someone gives me more details into it, I'm pretty happy. And also, if you know the details of each of these process or each of these messages, okay, the person you are trying to explain, it can, you're just simply explaining the person, or you may be giving an interviewer, or you're just sharing your knowledge, right? If you go into details of each and every messages that I've just drawn, right, it gives a whole lot more perspective about your knowledge, as well as it gives a whole lot perspective about the DORA process and your understanding about the DORA process. All right. So let's try to understand each and every single message in depth. So we have a PC, and then there's a DHCP server. Okay. Now, as I said, we are considering the fact that the PC and the DHCP server both are in the same network or are in the same IP subnet. All right. So the PC, as I said, the PC does not have an IP address, and that is why it wants an IP address. And that is what I said in the start, that the DHCP process or the DORA process helps networking devices fetch an IP address from the DHCP server, right? So for now, the PC does not have an IP address. All right. If it does not have an IP address, what will be the source IP? Source IP is going to be 0.0.0.0. It does not have an IP address. That's basically what it means. It does not have an IP address. Source IP is going to be 0.0.0.0. Right. Now, as I said, it sends a discover message. It sends a discover message. Now, if it has to send a discover message, as I said, we are talking from an IP perspective. If it has to send any message, there should be a source IP and there should be a destination IP as well. Source IP, we know that the source IP is 0.0.0.0. What will be the destination IP? Okay. Destination IP is going to be broadcast 255.255.255.255. This is going to be the broadcast IP or destination IP address. Why is it broadcast? Because as I said, the PC does not have an IP address. It does not know what the IP address of the DHCP server is. It does not know. Okay. So it cannot just simply it cannot just randomly choose any IP address and send the discover message. Okay. It cannot just do a guesswork. So it sends a broadcast discover message. Okay. With the expectation that if the DHCP server is in the same network, would probably listen to this discover message. All right. So source IP, destination IP, along with it, it also sends a DHCP ID. For example, that DHCP ID is, that DHCP ID is 123. Okay. So these three information, source IP, destination IP as broadcast, and DHCP ID. With this, it sends a discover message. Okay, since it's a broadcast message, every PC, every, not just PC, every device, every switches, every routers, even the DHCP server in the same network will receive this discover message. Will receive this discover message. Okay, including this DHCP server, every other device in the same network will receive this discover message as well. So now the DHCP server has received a discover message from a device which does not have an IP address, right? Now, what the DHCP server does is DHCP server sends back an offer message. Offer message. Now, what are the contents in this offer message? It sends an offer message with list of unused IP addresses, unused IPs, the address mask, okay, the IP address of DHCP server, the IP address of DNS server, the IP address of the gateway router. Gateway router. These are the few of the information that the DHCP server sends as an offer message to the PC. List of unused IP addresses, the address mask or the subnet mask, IP of the DHCP server, IP of the DNS server, IP of the gateway router. We are already learning what a DHCP is. We'll learn what is a DNS, and we'll also learn what is a gateway router in just a while. Okay. Now, again, the DHCP server, when it is sending back this offer message, the source IP, obviously the DHCP server has an IP address. So it will be the DHCP server's IP address. The destination IP, as I said, there is no IP address for this PC. Again, there is no IP address of this PC. So the DHCP server cannot choose any random IP address, right? So that means the destination IP here also is the broadcast IP address. Is the broadcast IP address 255.255.255.255. The offer message is also a broadcast message. Okay, along with the source IP and destination IP, it sends it also adds the DHCP ID of 123. All right. So this offer message again is sent to every PC in the network. Every PC will receive it, but only this PC or PC number 1 will accept this offer message because it has raised a discover message. It has raised a discover message. It has received an offer message for that discover message. And only PC number 1 will accept this offer message. Okay. Any question till here?
Yeah, at this point, it can't send directly yet because this PC doesn't have IP already. So it has
Yeah,
to send a broadcast only. But
correct.
broadcast sending, if other PCs receive, then what will happen? So they will reject it because
Good question. They will not react. They will simply drop it. That is why we also have a DHCP ID. Okay. If there is a DHCP ID generated, or if there is a if a discover message is generated, there will be a DHCP ID. Okay. And if my PC over here, let's assume, let's think from this perspective. There is a PC number 2 and PC number 3. PC number 2 and PC number 3 also in the same net. PC number 2 already has an IP address, for example, 10.10.10.10. Obviously, it will not, because it already has an IP address, it's not going to send a discover message, correct? If it receives an offer message, obviously, because it did not send a discover message, it will not even accept this offer message. First scenario. Second scenario, PC number 3, it also does not have an IP address. It also does not have an IP address. So it will also send a discover message, correct? Which is a broadcast. It will also receive an offer message. It will also receive an offer message, which is a broadcast. Now, this offer message can be for the PC1. The offer message that is received by PC number 3 was supposed to be for PC number 1. I hope you're getting this point. PC1 and PC3 both do not have an IP address. They sent a discover message. Okay. The offer message that was supposed to be for PC number 1 is also received by PC number 3, right? But PC
How
number
how
3
it
will
will how it will know it is for PC number one the offer message? So that two discover message, the two offer message the DHCP server will be sent to like two broadcast or one broadcast only it will send like based on the
yeah,
both
there will
the
be one
PC1.
broadcast. See,
Okay,
yeah,
PC1
that's
and
what.
PC3
Let
both
me
will
let
select
me
up.
let me complete my statement first. I'll answer your question. Let me just complete my statement. So the discover message, right? The discover message over here that was sent by PC number 1, right? For it, the DHCP server is going to send the offer message, which is a broadcast. And this offer message, which is supposed to be for PC number 1, is also received by PC number 3. Correct? But PC number 3 is going to reject this offer. Why? The reason is because of this DHCP ID. When PC number 1 or any PC generates a discover message, it creates a unique DHCP ID. So every time the server, DHCP server responds, it will add the DHCP ID as well. So now when PC number 3 received this offer message, it will see the DHCP ID as 123. But whereas PC number 3's discover message would have some other DHCP ID, for example, ABC. ABC is not equal to 123, and hence PC number 3 will know this offer message is not for me, it's for someone else. Clear? I hope I answered your question.
And yes, this it's clear now.
Okay, so over here, the offer message, the DHCP server has now given it a list of IP addresses to choose from. Okay, now let's say the PC chose one of the IP address. It chose one of the IP address. When it chooses the IP address, it will send a request message. It will send a request message. And what is the content of the request message? It will say that I'm using this IP address. Like say it chose one IP address. Like no, it will the chosen IP address, okay, and the IP address is address mask. It will also say this is the DHCP ID, DHCP IP. This is the DNS server IP, and this is the gateway server IP, gateway router IP. These are the messages, or these are the contents inside the request message, especially the chosen IP address. This is what we're looking for. It sends this request message to the DHCP server. Now, when it is sending this request message to the DHCP server, what will be the source IP and what will be the destination IP? Can you guess?
Source and destination IP. Right? The source IP, this will be the selected one, what is selected, and destination will be the IP of the DHCP server, which it is already there in the response
Okay.
offer.
Yeah. All right. Now, this is where, again, in the interview, they twist the question like how I twisted the question. Okay. Source IP is again going to be 0.0.0.0 because it's a request to use this IP address. There's a request to use this IP address. It has not been acknowledged. It is the request to use this IP address, the address mask, the DHCP server IP address, the DNS server IP address, and the gateway router's IP. It's a request. It has not been verified. It has not been acknowledged by the DHCP server. And hence, the PC still does not have an IP address. The PC still does not know the IP address of the DHCP server. And that is why the destination IP again here is a broadcast. Got it?
Destination IP of DHCP is sent, right? So in the offer, so it can
As I
send
said,
back.
it's a request to use these IP address. It has not been acknowledged by the DHCP server.
No, not the
It's a
source.
request message.
No, the destination. Destination.
Yeah, that's what. That's
Des-
what. Any IP address. That's what I'm saying. It know it, it knows the IP address of the DHCP server. However, as I said, it cannot use that particular IP address until and unless the DHCP server acknowledges this request.
okay.
That is why it is saying I have chosen the IP address. This is the address mask. This is the IP address of the DHCP server, DNS server, and the gateway router IP. It's a request that it is saying that I will start to use these IP addresses. It's a request. Okay. And when this request is acknowledged, the DHCP server, upon giving the acknowledgement to the PC that it can now use the IP address, the address mask, the DHCP server, DNS server, gateway router's IP address. The DHCP server receives this request and it sends back an acknowledgement. Okay, now you can use this IP address. When this acknowledgement is received by the PC, that is when the PC will now have an IP address, for example, 10.10.10.10. And now if it has to talk to the DHCP server, it will use the DHCP server's IP address. So until and unless, here also, when the acknowledgement is being sent, when the acknowledgement is being sent to the PC, the source IP from the DHCP server is the DHCP server's IP address, right? The destination IP, as I said, it is an acknowledgement. The acknowledgement is not received by the PC, and hence again the destination IP is going to be broadcast with a DHCP ID of 123. Once this acknowledgement that the PC can use the chosen IP address, it can use the chosen address mask, DHCP, DNS, and gateway router's IP address. This acknowledgement reaches the PC. That's when the PC now will have an IP address of, for example, 10.10.10.10. It will have an address mask, for example, 255.255.0.0. It now knows the IP address of the DHCP server. Let's say that is 10.10.10.1. It now knows the IP address of the DNS server, for example, that is 8.8.8.8. It now knows the IP address of the gateway router, that is, for example, 10.10.10.2. So until and unless the acknowledgement is received by the PC, all the communication between the PC and the DHCP server is a broadcast message. Any question?
No, it's clear now.
Clear, right? So this is the in detail explanation of what basically happens in a discover message. Okay, so when the PC is sending a discover message, it does not have an IP address. It does not know the IP address of the DHCP server, DNS server, gateway router, etc. Nothing, right? So when the discover message is sent, the IP address is so source IP is 0, destination IP is broadcast, and it has a unique DHCP ID of 123. Discover message is sent to DHCP server. The DHCP server, upon receiving this discover message, it sends an offer message which has the list of unused IP addresses, the subnet mask or the address mask, IP address of the DHCP server, IP address of the DNS server, and IP address of the gateway router. And again, as I said, there is no IP address on the PC. That is why the destination IP from the DHCP server side is also broadcast. The PC chooses one of the IP addresses. Okay, the PC chooses one of the IP addresses and sends a request message saying that, can I use this particular IP address? With that, I will be using this address mask and the DHCP server. This is the DHCP server's IP address, DNS server's IP address, and gateway router's IP address. Can I use these IP addresses? It's a request that is sent from PC to the DHCP server. Upon receiving this request, the DHCP server sends an acknowledgement. And in that acknowledgement as well, the destination IP is a broadcast. As I said, the acknowledgement has not reached the PC. It's still with the DHCP server. And that is why the IP address in the destination site, destination IP, is a broadcast IP from the DHCP server side. That means till the acknowledgement is received by the PC, all the communication between the PC and the DHCP server is a broadcast communication. Once the acknowledgement is received, the PC now has an IP address. It knows the address mask. It knows the IP address of the DHCP. It knows the IP address of the DNS server, and it also knows the IP address of the gateway router. And now, whenever it has to communicate with the DHCP server, now if it needs to communicate with the DHCP server, it will not send a broadcast. It will send a unicast where there will be a source IP of 10.10.10.10 and a destination IP of 10.10.10.1. This will be a unicast communication rather than a broadcast communication. Clear? Any question?
No, yeah, it's clear.
Now, this IP address that has been assigned or chosen by the PC, okay, it is given in a lease, or it is basically a rented IP or leased IP. Okay. In our example, we chose that IP address as 10.10.10.10. This IP address is basically a leased IP address, and the lease time is 24 hours. The lease time is 24 hours. So after 24 hours, the PC will lose this IP address 10.10.10.10. It will not have this IP address. It has to again request for an IP address from the DHCP server. Okay. Now this is the lease time of 24 hours. So for example, now let's say that at 9 p.m. At 9 p.m. the PC requested for an IP address and it got the IP address as 10.10.10.10, for example. Now, after a period of 12 hours, that is at 9 a.m., it will again send a request to the DHCP server to extend the lease time. After 12 hours, once the IP address has been assigned, so after 12 hours, the PC again sends a request message to DHCP server to extend the lease time. Okay. If the server, once the server acknowledges, now the time is for again, it will be extended for another 24 hours. That means from this IP address 10.10.10.10 earlier was from 9 p.m. till 8:59 p.m. Correct? It was till 8:59 p.m. or 8:59.59 p.m. 8 hours 59 minutes 59 seconds p.m. Okay, it was still here. But after 12 hours, when the request is sent to extend the lease time, it gets extended to 8 hours 59 minutes 59 seconds a.m. Next 24 hours. It gets extended to the next 24 hours. Now again, after 12 hours has elapsed, that means again at 9 p.m. the request is sent to the DHCP server, extend the time. Once the acknowledgement is received for this extension, again the time gets extended for another 24 hours. That means till the next 8:59 p.m.
If every 12 hours it is going to update, why it is giving it for 24 hours? Every 12 hours it is
Because the
keep on
lease time is for
updating.
24 hours. Lease time is 24 hours.
And that is where it is fixed. It is like manually fixed somewhere. It is by default some.
It's a default time.
So then it can do it after like just 24 hours completion. Before also it can do. Why it is doing a 12 hours request thing?
Because sometimes what happens, there are outages. Okay, sometimes there are outages. Sometimes it may be like your DHCP server may not respond. Okay, so that 12 hours buffer time is for a safer period. Okay, let's say that yeah, your Dora process got over at 9 p.m. You now have an IP address. So if it starts to request at 8:55 p.m. the next day for extension, and what if the DHCP server is unreachable? What if the DHCP server is unreachable, or what if there is a problem with your net? Your request message obviously will not reach the DHCP server, or you both the DHCP server and the PC will be unreachable. Okay, and if they are unreachable, and that means at exactly at 9 p.m., your laptop will lose the IP address, and you will not be able to communicate through the internet. So to have a 12 hours buffer time, it is designed in the Dora process, or it has been fed into your laptop or your mobile phone or even your smart TV to send a request message to the DHCP server to get an extension.
Okay,
Now
so
you
if
may ask. Now you
so
may
if
ask,
at
what
that
if?
time, if it is
uh,
like that 12 hours, that time if the system is having outage or that time, then will it send again or it will
yeah, it will try to send. It will try to send the request message. Okay, so at let's say at 9 a.m., it will send a discover message. Okay, if it does not receive, not discover, sorry, request message. If it does not receive a response, it will keep on sending the request message till it receives an acknowledgement. So at 9 a.m., at 9:30 a.m., then 10 a.m., 10:30 a.m., 11 a.m., 11:30 a.m., it keeps on sending request message till there is an acknowledgement received from the DHCP server.
okay about the extension?
Sorry?
About the extension, right? That it
Yeah,
is
about the
time is
extension.
extended.
Yes, about the extension. Yes. Okay. Now, like long back when I was giving an interview, yeah, during my early like days in the career, someone asked me a question. Now, there are two PCs, for example, PC number one and like not two PCs, one PC, and there are two DHCP servers, okay, DHCP one and DHCP two servers. Okay, it sends a discover message. Obviously, because it's a broadcast message, it will be received by both the PCs. The discover message is going to be received by both the PCs. Right now, obviously, if the discover message is received by both the PCs, offer message will also be sent. Offer message will also be sent by both the PCs. Right now, the question was, which offer message will the PC accept? Which offer message will the PC accept? This was the question. Okay, can you answer?
The
I,
first one, what it gets, it will accept, and it will second one, it will tell that I already have it. I don't want anything.
so you are saying it will accept DHCP once offer message.
First, first one, which the process we started is not one thing. No, it is four steps will be there. So first time it will send, then it will send back again. Like DORA process will happen, right? It will send the discovery, this
Hmm.
request, response will happen, acknowledge happen, then only the thing. So first one which process start that will end first. So once it gets the IP, it will like second one it will drop it.
No, no, no. Again, as I said, it is sending the discover message, right? As I said, discover message is a broadcast message. This broadcast message will be received by both the PC, both the servers, right? It will be received by both the DHCP servers. And in response, to the discover message, both the DHCP servers will send back an offer message. Both of them will send back an offer message from DHCP1 and offer message from DHCP2. The question is, which offer message the PC will accept? That's the question.
So
Is
this
the question
time,
clear now?
yeah, so this time it will just send a request for that offer, right? So it will get the offer, it will request
No,
again. Okay,
that's
this
what.
IP is
Will
correct.
it send a request for offer one or will it send a request for offer two?
Okay, okay. Maybe which one it received first, the
Exactly.
first offer which it received.
Exactly. Exactly. That's the correct answer. Whichever offer it receives first, it will communicate or it will complete the DORA process with that DHCP. So if it receives offer number one first, it will talk to DHCP1. If it receives offer number two first, it will talk to DHCP server 2. So all the other communication, all the next communication will happen with that respective DHCP server from where it received the offer message first. Clear? Now, the next few things that I wanted to talk about was here. As I said, gateway IP address, right? In the offer message, it also has the IP address of the gateway router. Now, what is a gateway router? What is a gateway router? In Mumbai, we have the famous Gateway of India, right? In Mumbai, it's a famous, tourist spot, Gateway of India, where you have sea in the background and there's the port. Okay, you can see like boats going over there, right? And you can see the sunset, etc. It's a beautiful scene, right? So this is the Gateway of India. Now, why is it called Gateway? Can you tell me why is it called Gateway of India? Why is that name given? Just give me a generic answer. I don't want a specific answer
No,
as
just
to.
might, no, just might be that monument was built that time and a lot of paths were connected through that. And through that you can connect to a lot of cities by passing through this gateway. Maybe because of that it came there. So
Exactly, exactly. You're absolutely right. So, and first of all, it is at the Bombay. It's in Mumbai, and it's at the port. Okay, and back then, when we did not had obviously when we did not had aeroplanes invented, Mumbai was one of the cities from where sea routes were connected. Obviously, there were other as well. There was we had Chennai as well. We had the West Bengal port as well. Everything was there. But to go to the Western countries, okay, from many people from the eastern side, they used to land at the Chennai port and they'll travel across the Indian land, go to Bombay, and from Bombay, they will travel through sea to other countries. Like, so the gateway, okay, basically acted as the entry point and it also acted as the exit point, entry to India and exit out of India, both. And that is why it was called as a gateway. Okay, and that's why that monument is called as Gateway of India. Okay, so with that similar concept, we also have something called as a gateway router. Something called as a gateway router. And just like the gateway of India is at the border, is at the border or is at the Indian border. Okay, a gateway router is also at the border. Gateway router is also at a land border, you can say land border. Okay, a gateway router is also at a land border. Now, let's imagine we have PC number one, PC two, PC three. Okay, they're connected to a switch. Okay, which again connects to different PCs. So what is happening? This is a LAN. Okay, again, this you have a switch connected over here. Okay, and then again you have different PCs. This is another LAN. Okay, smaller LAN. And again, this is a bigger LAN network. You can call this as a bigger LAN. If you connect these two LANs together, this becomes a bigger LAN. Okay. So now obviously we want that these smaller LANs to be connected or to be connected outside their network, right? So what we are going to do, we are going to connect it to a router, which will take them outside their LAN network and help them connect to different other networks, other LANs in the network, or for example, other WAN as well. So what is happening is this router is basically working as your gateway. Okay, so any traffic or any data that wants to come inside your network, it chooses or it has to go through this gateway router. And if any data wants to go out of your network, it needs to go through this gateway router. That is what your gateway router means. Okay, that means, for example, this PC. Okay, as I said, in the DHCP process, in your DHCP process, in the offer message over here, the DHCP server is also sending the information of your gateway router. Why is this important? This is important because, for example, this PC has an IP address, as I said, let's say 10.10.10.10. Okay. And let's say it wants to talk to the Google server. We know that the Google's DNS server IP address is 8.8.8.8. 10.10.10.10 and 8.8.8.8 are two different IP addresses, meaning that they are not from the same address mask. They're not from the same subnet. Nothing matches for them. Okay, that means when if I do a ping or if I try to reach the Google server, my PC, this PC would know that 8.8.8.8 is not in my network. My network IP address is 10.10.10.10 and the IP address, the destination IP address that I'm trying to reach is 8.8.8.8, and hence this PC. Okay, obviously this PC or this IP address is not in my network. And if it is not in my network, I have to I have to send this data, or I have to send this data or forward this data to my gateway router. Then this gateway router will send the data to 8.8.8.8. This is why we need a gateway router's IP address to send data out of your network and to receive data from other networks or outside from the network. Clear?
Yes, yes.
Okay. So as I said, the on your PC you don't have to write the gateway IP address. It is fetched or it is received during the DHCP process. Clear? Then next, DNS server. What's a DNS server? DNS, domain name server. Domain name server. Okay. Now, when I type google.com, okay, this is a human readable name. This is a human readable name. And my PC works on IP addresses. Okay. So even if I type google.com, it is still able to reach the Google server. I am not going to write, okay, let me type an IP address. 8.8.8. Okay. So 8.8.8.8 is basically, if you see, it's the DNS.google. It is Google's DNS server. Okay. Or it is basically Google's proprietary DNS IP address. Okay. So, or if I just simply type google.com also, google.com, I'm not writing the IP address of the Google server. I'm not writing the IP address. Or if I just write facebook.com also, I'm not writing Facebook's IP address. Right? If I type netflix.com, okay, I'm not writing Netflix's IP address. I'm just writing netflix.com, google.com, facebook.com, and I'm able to get whatever you see on the screen. Right? But we know that whatever communication is happening, it is happening in the form of IP addresses. But I'm not typing any IP addresses. So how is this working? How is this working? That is where your DNS or domain name server comes into picture. Right. So when you type google.com, when you type google.com on your browser, okay, when you type this on your browser, what happens is that your browser, first of all, checks on your laptop. Okay. What does it check? It checks the DNS cache memory. Okay. We'll talk about DNS cache memory in just a moment. But please remember, it first checks the DNS cache memory. Let us assume that it does not find the IP address of google.com in the DNS cache memory. It does not find the IP address of the google.com in DNS cache summary. What it does is it will send a DNS query to the DNS server, which has a database. The DNS server has a database of IP addresses. Okay, IP addresses, not just few IP addresses, every single IP address in the world. It has the database of every single IP address in the world. It stores the IP addresses and their relevant human readable name. Okay, so with netflix.com, for example, okay, for netflix.com, for example, it stores the IP address, let's say 100.100.100.100. Okay, for google.com, that IP address is 8.8.8.8. For Facebook, that IP address is, let's say, 110.110.110.110, for example. Okay, so it stores the relevant human readable name along with the IP address. So when you type google.com on your browser is basically sending a DNS query to the DNS server asking, do you know the IP address of google.com? Okay, the DNS server then responds to your PC With the IP address, you have a DNS response. Okay, with the IP address of 8.8.8.8 as the Google server's IP address. Now this then gets stored in the DNS cache memory of your laptop. Now once your computer or your laptop knows the IP address of the Google server, now it can communicate using that IP address, using 8.8.8.8 as the destination IP address. It can send data to the Google server, and the Google server can also send response to your laptop. So now the next time when you do a google.com, there is no need for your PC to send a DNS query, because it will automatically look for the google.com in the DNS cache memory, and it will find the IP address as 8.8.8.8. So there is no need for a DNS query when you have it stored in the cache memory. Clear? This is what a DNS IP means, or DNS server is.
With this DNS query, this will also go through the gateway, right? It has to send
Yes,
some
this will also
request
go.
through
Yes, yes. Again, the DNS server may be in your network, may not be in your
local or
network.
outside.
If it is not, yeah,
How it
it
will be
can
the
be a
format
local
for
router
this?
also. Yeah.
Okay.
Again, that's a good question. That's a good one. That's a good one. So when you say a DNS server, or let's say a server, okay, that server can be your DHCP server, or it can be your DNS server as well. Both. This can be a dedicated server, okay, or it can be a router as well. It can be a router as well. Both. Okay. So DHCP server, obviously DHCP server does not have to hold. Okay. A DHCP server does not have to hold all the IP addresses in the world. It just need to hold the unused IP addresses that it has to assign it in the network. But if you make a router work as a DNS server, then the responsibility is a bigger one. Okay, so basically, a router is actually not given the role of a DNS server, because it needs to hold a lot of IP addresses. So if your network does not have a DNS server, that DNS query goes to your gateway router, and the gateway router then forwards that query to the nearest DNS server. So that is why we call that this router is acting as a DNS server, but no, the router does not act as a DNS server. There's a dedicated server for DNS.
Okay. So this
Clear?
query will be same as this what we do the discover message or request ping, like that kind of thing it will
No,
send.
actually, no. The DNS has a separate process.
Okay.
Okay. Honestly, even I do not know. It's a huge process.
Okay.
It's a huge process,
Even
and there is
this
not just
request.
one DNS server. There are multiple DNS queries that it sends to a DNS, for example, DNS server 1 and DNS server 2 and DNS server 3. All these three different servers play different roles for the DNS query that is sent by the PC. Okay, it goes to the DNS server, then the DNS server one sends a response to the PC. PC then sends message to DNS server 2. It sends back a response. Then PC sends a message to DNS server 3. Then it sends a response, and then it gets the IP address. So it's a huge and a bit of a complicated process.
Oh, okay.
So yeah, I'm not going in depth about DNS. Okay. So as I said, with your DHCP process, process, there are so many things that the DHCP process is able to resolve. How are you going to go outside your network? Using your gateway router. How are you going to convert a human readable name into an IP address? Through the DNS server, right? How are you going to extend? How are you going to extend the life of your IP address? With the help of DHCP server. So all this information is able to be fetched by the DHCP process, right? So DHCP is an important protocol or an important process in the life of any PC. And without a DHCP server, your network may go down. Clear? Any question?
Yeah, it's clear. So it has DHCP server has to be present every time. So once like laptop is connected to internet, if somehow DHCP server is down, it has to know any other DHCP server. Because otherwise, after
Yes,
24 hours, that is
yes,
down. If it
yes.
doesn't know about anything, it will be problem. No connection will be there.
Correct, correct. So there are
That
always
means
redundant DHCP servers.
that is present already
There is
multiple.
always, yes, there are backup DHCP servers in the network always. So this was
So,
about DHCP.
so from home laptop, right, when it connects, so like internet only it is available, like all the DHCP servers. So from home, this laptop will connect to internet. If it doesn't find anything, it will go and search one, not there, other, not there, through the gateway. But the gateway also comes from the DHCP server only, right? Gateway IP also doesn't know the laptop. So the first
Hmm.
time when I start it, so how it will know that one DHCP is not there, it will go to the other DHCP where it doesn't have that to send to the broadcast to like it is not to the LAN also, right? So like if LAN nothing is there, it directly I connect my like I take in an internet connection, I connect it to my laptop.
Okay. So DHCP is an inbuilt or hard-coded protocol for every laptop, for every networking devices nowadays. So the moment you connect it to the internet, okay, the moment you try to look for something on the internet, Google, it already knows Google is the Google browser that we use. It has a URL, it has an address portion. And the moment you type something and press enter, the your laptop, okay, will first, the moment you type google.com, let's say you are not connected to the internet, for example, and you went and typed google.com. Okay, first of all, it will try to convert it into the IP address with the help of DNS server. But then it will automatically know that it does not have the IP address of the DNS server. If it does not have an IP address of the DNS server, it has to go to the DHCP server to get that IP address. Okay, and then it will realize, oh, I do not have an IP address myself. I do not have an IP address myself. That means I have to request the DHCP server.
Right, right.
Now, okay, now what if the DHCP server is not in your network? Till now, whatever we understood about DHCP was from the same network point of view. What if there is the DHCP server is not in your network? Okay, so there's a router. Okay, it's not in your network. This DHCP server is not in your network. The discover message that is sent, okay, will reach only till this router. It is not going to forward it out to the other side. Okay. So obviously this discover message will not reach the DHCP server, and the DHCP server will never send back an offer message. Correct. Because the broadcast will never go out of other interface or
Yes,
go to
right,
other network.
right, right.
Okay. So what will happen is we have to configure this router as relay agent. We have to configure this router as a relay agent. I'm sorry, I cannot show you all this DHCP process practically because obviously, on even on your Cisco packet tracer, DHCP showing the DHCP process is like a bit complicated. It's not easy to set up. I will not be able to show you. I can only explain you theoretically. So what this relay agent? What is this relay? We have seen relay race, right? We have seen Usain Bolt's relay race a lot. Okay, so what happens over there? Okay, there's a one racer. He will race 100 meters. Okay, and then he'll pass the baton to the second racer. Right, second sprinter will then pass on this baton to the third sprinter, and then finally you have the Usain Bolt from Jamaica, and then he'll run the last 100 meters. Right. So what is basically happening? They are passing on this baton to every sprinter. Right? What happens is basically that's what you call it relay. You give that chance to other race, or you pass on this baton to the next sprinter. Similarly, this router, we have to configure this router as a relay agent. Relay agent for what? Relay agent for your DHCP. So any DHCP message that is received by the router, it will be forwarded to the DHCP server. And the DHCP server will then respond, and the relay agent will forward that response to the PC. Clear?
That will be only one DHCP server. If the it will the router is configured only to one DHCP server, not multiple. If one is down, then again it will search for other, or it will there was earlier given
See,
example of two DHCP
it's
servers.
basically relaying. It's not. It is relaying. It is not changing the IP addresses. What is the IP address? Destination IP address over here? Broadcast. So if okay, so over here this DHCP server, this DHCP, we make sure that the DHCP server is not too far off geographically located. Okay, so we want the DHCP server to be like not theoretically, even in real life, we want the DHCP server to be as far as just one router, so that I have to configure this relay agent only on one router. So what is going to happen? This router,
Oh,
when it receives the broadcast, it is simply relaying or forwarding this discover message to the DHCP server on this network. And here
so
also the
one
destination
router,
IP is
one
going to be
DHCP.
broadcast.
So one router, one DHCP servers. So one router will not connect to multiple DHCP. So suppose it tries to go
It
to
can
the
be connected
DHCP
to
server, it
multiple
is down.
DHCP servers. No, it can be
Okay.
connected to multiple DHCP servers.
So if one is down, then it will check for the other one.
So it won't check for the other. As I
Oh,
said, whoever receives the discover message first and whoever sends back the offer message first, only that particular offer message will be forwarded.
no, I'm thinking first time when the discover message received to the router. Okay,
Hmm.
then it forwards to one DHCP server, but that is down. Now what will happen? It is not able to by the it
See,
knows that it has a
that's what I'm
DHCP
saying.
server at
See,
this side.
let's say this is DHCP server 1 and DHCP server 2.
DHCP two.
Okay. And this is a switch. Okay. So when this discover message is forwarded, it will be sent to DHCP 1 and DHCP 2 both. And if this DHCP server is down, obviously the discover message will be received by DHCP 2 only. Right.
Okay, okay, like this the okay, like this the connection. I thought it will be okay
No,
through
you
a
cannot have
switch.
single connectivity. See, a router interface, if you connect like this, DHCP 1 and over here DHCP 2, okay, these are two different router interfaces. If you have two different router interfaces, the this network is different, this network is different. Okay, the IP address that you assign this IP
Yeah, it is
network
this.
is different, this IP network would be different. So obviously the broadcast will not be sent to both the networks. Then you have to strategically choose to which interface do you want to send this relay message. Do you want to send it to DHCP1 or do you want to send it to DHCP2? So that is why it is always preferred to have a switch in between in order for us to have connectivity to both the DHCP servers. Got it? So this was about DHCP today, and I hope to start OSPF.
So this was the full thing, DHCP like 1